This is on line 2.6, number 5. Okay, and the function I'm looking at is 2x squared plus 5x plus 6 and 2x squared plus 2x plus 1. You have the difference of two square root functions. Okay, so where are we taking this limit to? We're taking the limit as x goes to infinity. So this indeterminate form is actually sort of an infinity minus an infinity, right? Which you might think, oh, well, it must go to 0, right? But actually, it goes to a specific number. This subtraction of two things going to infinity is indeterminate. Indeterminate. There's determinate. Okay, and so as x gets bigger and bigger, this goes to infinity, and this goes to infinity. So they maybe balance out somehow and converge to a specific number. And we'll see how that happens, or at least we'll see how to prove it algebraically. But then you can also plug it into your calculator and look at the limit just as I was doing with that other one. So if I have, here's the square root of 2x squared. Oh gosh, I already forgot it. 2x squared plus 5x plus 6, and then it's 221 for the other one. Okay. And then minus square root of 2x squared plus 2x plus 1. And what we want is we want to find the limit as x goes to infinity of this quantity, f of x. Okay. Now, you might be thinking, we never did one like this in class. Well, you're right. But we did look at the algebra that would allow you to do this. So there's a lot in this problem, and we may want to stop to look at a simpler version. But here goes. Anyway, so if you look at this thing, I'm going to write it out again. 2x squared plus 5x plus 6. You might be remembering that, well, we only have a few algebra tricks up our sleeve. What are our algebra tricks? This thing right here looks like square roots and there's a subtraction. It seems like it's just begging to be multiplied by the conjugate. But you can't just multiply by things. You can only multiply by something that doesn't really fundamentally change it. Okay? And oops, I did it again. I need my limits here. Limit, I'm going to write it on the next line, as x goes to infinity. Okay? But so if you turn this whole thing into a fraction, then what we can do is multiply top and bottom by the conjugate. Okay? So I'm going to write this plus this. I'm going to kind of do a shorthand here. And I'm going to multiply top and bottom by the conjugate of the numerator. See, we're allowed to do this because this is equivalent to 1. I guess I'll write it in for this is 2x squared plus 5x plus 6. Here's 2x squared plus 2x plus 1. Here's, and then this is the exact same thing. And then this one is 2x squared plus 2x plus 1. Okay, so, and then all of these things are under the square root. Okay, and what happens is we're using this formula that here I had a minus b, and I had a plus b, and if I multiply them, then I get a squared minus b squared, right? And what happens when I square a square root? The square root sign goes away. So the next line of this is really, and I'm going to write my limit sign. I'm going to be a good role model because I will yell at you if you forget to write it. So I shouldn't forget to write it. That's the limit sign. This becomes really now 2x squared plus, that's plus 5x plus 6 minus, in parentheses, 2x squared plus 2x plus 1. All over, and I just have, this down here. I'll leave this in blue. This is going to be 1 times this whole thing. So this you know, square root minus square root. Okay? And so if we start cleaning up the top now, we should get something that looks nicer. You end up with, oh, lots of things cancel. And you end up with, oh, good. A hand, yes. So Stephanie, oh, okay. So first, right, good. Multiply by the conjugate. And Alexander asked, can we square the whole thing? No, because that actually wouldn't help you. If you square the whole thing, you'd still have square roots in the problem. And I think that we have to, in order for you to do it all the way through, you're going to have to, you're right. No, actually, Patrick is right. We're gonna have to. We'll go through it. Let's go through it. I think I'll answer all your questions. But Patrick is right that I made a mistake. This is supposed to be a plus because that's we did, and you we multiplied by the conjugate. So these two should be different. These should be opposites, right? So now what I was doing is finishing combining like terms, and I think we can show you how to go after that because there's still a little bit more to this problem. We are not done. Okay, so this is 5x minus 2x is 3x. 6 minus 1 is 5. Okay, then we end up with this thing down here. Okay, this becomes, and now I have to write it all. This is going to be square root of 2x squared plus 5x plus 6, and Patrick, being on the ball, recognized I needed a plus sign there, 2x squared plus 2x plus 1. Okay, good. So this is, and I should clarify this because this is important. This is a 3. Okay, that's a 3x. And that came from, what did I do from here to here? I combined like terms, okay? All I did was just combine like terms from here to here. That's what got me from there to there. Okay? Now, right. So 2.6, number 5 continued, or number 6. This was number, yeah, no, it was number 5. Okay. Number 5 continued. Took an aside there. Now we're coming back to it. Okay. Now, what happens when we factor out the lead terms for this problem? Okay, so this is going to equal, this is the limit as x goes to infinity of, I have 3x here, and then what is the lead term for this one? Notice here's a 2x squared and a 2x squared, but it's inside the square root. So really, I'm factoring out square root of 2x squared. Okay, and what would I multiply by to get the same thing back if I were factoring out the lead terms? In this case, it's going to be 3, so 3x plus, I have 1 plus 5 over 3x. But now let's look at this denominator over here. Okay, this denominator over here is if I distribute a square root of 2x squared back in here, what would I need to be multiplying this by to get our original expression back? Well, this is 1, okay, plus, well, maybe I should put more steps in there, but this is basically what happens. This is 5x over, and it's gone, well, this is what it is. And then I have plus, okay. This one's going to be square root of, I have 1 and this is plus, this is going to be 2x over 2x squared plus 1 over 2x squared, like that. Okay. That's probably a little weird. Okay. And what happens is that here's the note I want to make, which is that for in general, right? If I have something inside a square root and it's being multiplied together, okay, you can pull them apart and multiply the square roots separately. Okay, so you can separate square roots like that. And what's happened here is that I pulled 2x squared out of here, right? So this was the lead term of that part. This is the lead term of that part. They happen to be the same. I factored them out of each one and then pulled them out as the square root. So then you end up with this here. This is the algebra part that may seem like magic, but maybe you follow it. But what I did was correct. And you can now simplify. Let's simplify this a little bit. This is still 3x, and what happens as x goes to infinity? This thing is going to go to 0. Okay, this thing is going to go to 0, 0, 0, 0. All these things that have an x in the bottom are going to 0. Okay, and what's left over is that on the top you have 3x times, that's just 1 plus 0. And then I have, notice this part here. I have the square root of 2 times, what's the square root of x squared? The square root of x squared is actually technically the absolute value of x, but since x is greater than 0, and I want to look at that in a second. So x is greater than 0, which means that this is just x here. Okay, so I took the square root of 2 and I took the square root of x. And then what's left all up in here is square root of 1 plus the square root of 1. And this stuff, these x's cancel out. These two combine to become 1. And you end up with that this limit is really just essentially 3 over root 2 times 2. And so I believe it is 3 over 2 root 2. I believe that is the answer. Let's see what my answer sheet says. Okay. So this is the exact value of the limit. Okay, did that seem like x? Thank you. Yes. That's right. That's right. Okay. Good. And you can estimate these using a calculator just like we were doing before. Okay.